Notice we are giving a function 1 over x minus 1, and they're asking you to come up with the first four terms in the general term again. Okay, now we can, I always check if it's in the form a over 1 minus r, and it's not because it's actually x minus 1. If it was 1 minus x, it is the sum of a geometric. You can make it fit this form, but it's a little bit more complicated. So I'm going to go ahead and do this problem by actually calculating the derivatives. So remember, what you want to do is start with the first term, which is going to just come from the function 1 over x minus 1. And let's not use the quotient rule, just think of it like this. And let's calculate, I need to get to the first three derivatives to get to four terms. So my first derivative, bring down the negative 1, reduce the power by 1. If you want to simplify it, that would be fine. Second derivative is going to be bring down that negative 2, reduce the power by 1. Third derivative, negative 6, x minus 1 to the negative 4. And then the next thing we're going to do is we want a series about x equals 2, so that's our center, so you need to plug in x equals 2, and these are the numbers I'm going to work with, 1, negative 1, 2, and negative 6. Once I have those numbers, I can go ahead and calculate my series. So the function is, you start with f of 2, which is in this case 1. This is your next derivative, negative 1. We are centered about 2, so you have x minus 2. The next term is 2, x minus 2 squared over 2 factorial minus 6, x minus 2 cubed over 3 factorial plus dot dot dot. Okay, I'm not going to write the general term yet. So sometimes when you have to write the general term and you don't see a pattern easily, this is where you might want to simplify a little bit. So notice what's happening to the numbers on the top and the bottom. 2 over 2 factorial just becomes 1. 6 over 3 factorial also becomes 1. So this is my series. Now if I write it like this, much easier to write the general term. I notice it's alternating, so I need that. I also notice all you're doing is it's x minus 2 to the n. Put that in the middle, do a plus dot dot dot. Okay, part B. It says use the result from A to find the first four terms and the general term for natural log of x minus 1. So again, you can do this problem by taking the derivatives of this, like we did here with this function, and doing it this way. But it says specifically to use your answer from part A. Well, what you need to do is think about, okay, in part A, we created this series. What's the relationship between this and natural log of x minus 1? Well, if you notice, if I take the antiderivative of 1 over x minus 1, this is natural log of x minus 1. And then I would have a plus c also. So instead of recreating all the derivatives, this is this series right here. So if I integrate this series, I will get to the series for natural log of x minus 1. So ln of x minus 1 is the antiderivative of this series. Antiderivative of 1 is x. Antiderivative of x minus 2 is x minus 2 squared over 2. And keep going. X minus 2 cubed over 3 minus x minus 2 to the 4th over 4. And don't forget now, you will need that plus c. Okay, what you want to do to find that plus c is you need to pick a point to use. Always use the center, that's the easiest to work with. So I'm going to plug in x equals 2. If I plug in 2 here, this becomes natural log of 1, which is 0. If I plug in 2 here, this becomes 2. Every other term in this series becomes 0. This is what I have. We just said natural log of 1 is 0, so c is really negative 2. So I have natural log of x minus 1 equals, we just said this is negative 2. Well, I can group this and the negative 2 together, and really, I can rewrite that first term like this. And now, notice it says, specifically, you want a series about x equals 2. That's why it works out this way. I want the first four terms. Okay, I'm going to keep going down here. So here's my first four terms. And it does say to write the general term, so plus dot dot dot. I notice it's alternating. I have an x minus 2 to the, if I start the negative 1 to the n, in order to start with n to the first, if I start with the 0 to make it positive, you will need an n plus 1 in the x minus 2. So the number on the top and the bottom also match up, and then put a plus dot dot dot. And skip part C.